quick introduction. Today's hosts will be myself and Alonso Trejo Mora. Feel free to introduce yourself, Alonso.
Thank you, Wesley. Good to meet everybody. I work with Wesley on the Cloud Solution Architects team at VMware, specifically with the Cloud Management Business Unit. The data center administration is a big part of what we help customers day to day with, and with the VMware portfolio as well.
Right, and I'm Alonso's counterpart, just in a different territory. We handle the Aria suite. We demo it, we troubleshoot it, we run our own labs in it. Today, we're going to be dealing with Aria Config, which handles state management. On your screen in red, you should see a quick, brief overview of exactly what it does. And what it does is it deploys many scripts across many VMs, specifically many subsets of VMs, helping you to accomplish a lot in the command line without having to reproduce your efforts across every single VM, which can be a bit of a workhorse if you have 500 VMs. Let me provide a quick overview of how config fits in. The DevOps lifecycle begins with planning. You get your brain trust around a table, figure out where you need to spend your efforts. Once you figure out what that project's going to be, you start to code it up and you start to build it and you test it. You do your unit tests, making sure that the application works as it should. Before releasing it to your ops team is going to go ahead and deploy it on the infrastructure. They're going to operate it, monitor it for KPIs such as availability, such as CPU usage, and that type of thing. And then ultimately, it goes right back into the planning phase as you figure out what next project needs to be built out. But this is where all of our different solutions factor in. Aria Config is a tool that is meant mostly on a day 2 type of operation. So day 0, you've established your infrastructure. Day 1, you're maybe doing your initial updates, maybe installing your middleware and your endware. But day 2, when you need to troubleshoot, day 2, when you need to patch, and just ongoing things that happen after the infrastructure is initially set up, you're going to be needing to work in the command line. Your developers or your IT operators are going to need to work in the command line. And again, that's where Aria Config is going to help you to scale your efforts. What Aria Config does is it initiates and it controls for desired state. So you might want to establish an initial state with a certain number of vCPUs allocated, certain amount of RAM allocated, certain parts of software allocated, the ability to harden your environment and make sure that certain parts are not exposed to the internet, certain pieces of the hardware are shut down. You want to make sure that certain hardening is in place. That's a desired state. What running any particular number of salt states, which we'll get to, but what running a salt state does is it examines that VM for a number of different properties. And if those properties are not aligned with the desired state, it will put them into the desired state. And we'll get into exactly how that happens. But some of the terminology, so that nobody's confused, is that Aria Config is a graphic user interface, GUI, built on top of Salt. Salt's an open source platform. Salt competes with Ansible. They're very similar, but they do have differences. Ansible is an agentless workflow. Salt has an agent. Salt can also do agentless, but the chief difference is that Salt has an agent, which allows it to have more control over certain granular functionality on the operating system and allows it to do slightly more. Ansible, because it's agentless, can be installed or can communicate with a network or router versus something like Salt, or in this case, Aria Config, it requires an agent being installed. So it might not be able to take care of the workflows that are dealing with networks and switches where you can't install an agent. But some of the big advantages of using Aria Config over an Ansible command line is you do get role-based access permissioning. You do get the directory integration so that when people log in, they have certain permissions available to them and they can do certain things and they can't do other certain things. You get a very easy to read interface with activity history. You can see what's in progress, what failed, gating, compliance approvals. And also one of the big things that you can do with an agent or a minion installed is you can create a beacon reactor workflow, which means instead of having a scheduled basis or an ad hoc basis on which you run these desired state files, you can have them be reactive in real time so that if a VM goes down, the master will know immediately because the agent is no longer communicating back to it with a ping, and it will run some salt state file that gets it back up and running. So that's just a quick dirty use case for why a proactive monitoring solution that you would get with Aria Config has a competitive advantage over something like Ansible, which is widely adopted because it is open source, but it's not the best product for an enterprise where you want to scale beyond your one particular person or two particular people who understand that workflow perfectly. If you want to scale it across a team, you'll need a GUI. That's where Aria Config comes in. And I've provided some of the other use cases over here, from installing middleware and endware. That's one, or just being reactive, helping you to recover from a disaster recovery scenario like we discussed before. Everybody with their own personal laptop or personal computer has dealt with a PC crash. And if you are like me, you've had to deal with lots of those. Now, after the PC crashes, the first thing you might realize you have to do is you have to install the operating system, kind of a base layer. Then you have to reinstall applications on top of your operating system, like your endware. Then you might have to reconfigure the application, set up the user, the passwords, that kind of thing. And of course, you're going to have to troubleshoot because things never happen the way you want them to. And of course, the patching, and then ultimately saving a backup. Now, how this translates to your enterprise is you have to do all those same operations, but they have to happen in bulk across many VMs. So you have to reinstall all of your operating systems, all of your middleware, all of your package dependencies, and so forth. Now, that's one particular use case. Let me hand it off to Alonso, who can discuss in detail some of the application deployment.
All right, thank you, Wesley. As part of the ongoing administration of endpoints or virtual machines, right, whether it's on different flavors of Linux or different kinds of Windows endpoints, Windows Server, Win 10, and so on, all of those are going to require some kind of configuration. For instance, if we need to provision new virtual machines, we're provisioning some kind of server, whether that be a web server or a database server or a developer tools server, right? Or some other kind of service that we're providing on a virtual machine. Or it could be a container as well. Some kind of configuration needs to be done in the operating system to add users, create packages, and install them. All of that together creates the delivery of a given service. Where we're going to be focusing on today is mainly on the area of configuring these services scalably. So when we're creating a service for the first time with virtual machine creation and container creation, right, as an example, how do we then start implementing and applying states to these foundational layers, to this infrastructure, so that it becomes an Nginx server, it becomes a database server, right? And that's going to be the focus there from a creation and perspective and deletion perspective, as much as a day two operations perspective. There are several cheat sheets available to you in order to actually understand what kinds of commands do I need to run in order to accomplish a specific action. So for instance, if we wanted to restart a minion or check on a minion version or install a specific version of Salt, right, into our system, right, which is how we would essentially install the minions. Here, there are pages available, and we will make these available after the call as well, describing how do I actually go about, for instance, deleting a folder or creating a new file within one of my endpoints. Or additionally, how do I create symlinks, or even doing things from a perspective of checking for audits, which there's compliance checks in the platform as well. So all these different actions, administrative tasks that you might need to do on 1, 10, or 100 different machines can all also be referenced as we go through some examples here. When it comes to actually running commands on Salt, we first have to install minions on our different endpoints. And so it's as simple as essentially installing Salt on Windows, Ubuntu, Debian, and so on. And once that minion service is installed and activated, there is a key exchange that needs to be done where the minions will then try to find and report to a master. Now, during that process where they try to find a master, what essentially happens is there's a key acceptance. So you will find keys that are pending from those different endpoints that want to connect to the master. Once those keys have been accepted, then we can run in-mass commands across all of your different minions. And what that allows you to do is then do things such as target Windows machines, Linux machines, front-end machines, database machines, and so on. The main key point here is that you have a central location of management whereby you have your minions in inventory.
But creating a target group is as simple as if you just hit that create button. I just want to make it painfully obvious that this is pretty easy. We give it a name, and then we can do a filter. And the filter can be, hey, show me everything with an operating system that equals, and the operating system is considered a grain in SaltStack terminology. It's nothing more than a term. And we can select Windows, and we're off to the races. And you could do this with, look at those grain keys, Alonso, real quick, and we can add multiple criteria. But there's some of these are obvious, some of these are not so obvious as far as what they're filtering for, but there's a number of different ways to filter through your environment for a specific parameter to make it part of a certain subset. If we take a look at jobs over on the left, jobs has a similar wizard. And if you just hit create job, we can sort of see what's going on here. We give it a name. We can hard code a target. It doesn't have to be hard coded because you can always on an ad hoc basis indicate which target you want. But if it's a job that can only run on a specific target, that's where you would hard code the target. Functions, this is going to reference a whole bank. And again, if we think about that file server that Alonso showed earlier, that's where many of your salt state files and different actions that you can take are stored. And where do these come from? You can create them yourself. You can download them online. You can get them from the SaltStack repository. So, and I think many will also come from the plugin or the add-on that allows you to have all those out-of-the-box hardening measures as well. But this is creating a job. So again, jobs simply reference functions, modules, and salt state files. Oh, by the way, do you have the assembler open where we can see the topology of those VMs?
Yeah, absolutely.
So part of the Aria Automation Suite is config, which is what we're discussing today. But another part of it is assembler. In the top left, you'll notice the assembler. This is where you actually create templates that spin up infrastructure automatically. So this is more of a day zero type of operation. Our next session in September will actually go over this in detail, the assembler. But for now, just know that what assembler is doing is spinning up 5 virtual machines running on a cloud network. And we can see the Aria Config instance, and we can see the Apache, which is the web application server. We can see OpenCart, which is the web application running. And we have 2 ancillary VMs running, one on Windows Server, one on Windows 10. On the right, we have the addresses, the local IP addresses. So Alonso, if you click on the Aria Config instance there, we'll get on the right our IP address, which tells us where we can go to access Aria Config. So again, assembler spun up not only Aria Config, but it spun up the other VMs, and it created the username, passwords, and in fact, it also installed the minion master and the minion agents. So if we take a look, yeah, your environment might not have it, Alonso, but if you click on the Apache resource, you can click on that template too.
Yeah, we could show the template.
Yeah, so this is the administrative template where the YAML code was configured. The YAML code is just simply establishing what is happening. And on that right side, Alonso, for the YAML code, if you scroll down, we should see an instruction towards the bottom for any particular minion where we see the minion being installed. So if you scroll down a little bit more, and a little bit more. Okay, right there under the run command, we can see there the curl command, the curl with a flag O, bootstrap salt sh. Those 2 short lines, Alonso was showing you the cheat sheet, but those 2 short lines got the minion installed on the VM. And now the SaltStack config, which holds the master, can communicate with all of the minions which are installed on all of your VMs. So we'll go into depth again on assembler in September, so stay tuned for that. But back to you, Alonso.
And so with that context, now that we have our deployment environment established, the Windows virtual machines, the Apache virtual machines, and so on, well, now we have the minions deployed onto all of these. So what this allows me to do is I don't have to go into my individual instances now and run commands, right, to get information from those instances, or to reboot or start or stop services. That's something that I can do centrally from my master. So if we wanted to do something such as see what are my minions that are up currently, we could run a salt run manage.status as an example, part of our cheat sheet. Now what that does is tells us what are the minions in our environment that are identified as up and down. Similarly, we could do something such as we could check the version of salt and run commands on that as well. And here we get a response from all of our minions in what would be industry-wise record time. And the reason for this is because Salt architecture using an event bus is the most scalable in the industry. Now, from this additional perspective, we could see things such as what are some metadata components of my minions? I want to get the operating system. And we see this element called a grain up here that is essentially metadata that's a descriptor of our instances in our environment. Now, I've been running a couple of modules here. We see grains as an example. We see test as another example. How do I see what are these modules? Where are they? Where's a library where I can actually reference what is available to me? So there is our documentation here on modules. There are other elements as well. We see beacons, and we'll address these in a quick second. But if we go over to the modules section, actually, let's go here to salt.modules. There are a ton of different modules available that can be run on virtual machines. A particularly popular one that is worth calling out as well is modules.package. And what this does is it's essentially think of it like an abstraction layer where .package can be targeted towards a Windows machine. It can be targeted towards a Debian machine, a Linux machine, several different operating system options. And what specific OS package manager it uses will depend on the target, right? But package helps you abstract that complexity away when you're actually running your files, your state files that you'll run jobs with for, say, package installation or updating. That's just one example of how we can essentially abstract away the layers of complexity with working with different OSs.
Let me do a quick point there too, Alonso, just because I know that when I was first learning about Salt, the terminology starts to lose me. So essentially, what it comes down to is there's some there's different groupings. So at the top layer, you have a salt state file, which can contain multiple jobs in a single salt state file. And the jobs can contain multiple modules. Modules are almost like functions. In my mind, that's how I think of them. And you can have many functions and group them together and basically call that a job. And you can have multiple jobs and call that a salt state file. And you can have multiple salt state files and call that a top file. So there's a nesting structure going on here. But the point being is that when Alonso was there in the command line, he was running very, very basic commands, which are grabbing but basic properties, the OS running on it. But you can get very complex with exactly what this scalability can do across many different VMs. That's how you get into the realm of installing and configuring middleware, packages, endware, and even being able to configure the endware from the command line interface. Because ultimately, you don't want to take it back to the top where I was showing the example of when your PC crashes and you have to go in there and reinstall Microsoft Outlook, but then you still have to install or configure many different options to make it kind of tailored to your use. Some of that can be configured right from the command line. And if it can, then certainly create a salt state file that does it all for you. So it leaves very little to do in the GUI for your end user or for your admins. Back to you.
Yeah, an excellent point. And so as we start to get more advanced, shall we say, than the basics of implementation, that's where we can actually start codifying some of these actions as part of, as Wesley mentioned, a state, right? So these commands can actually be a part of an ongoing applied template, shall we will, or a state file that gets applied to our machines. So we know what a web server needs to contain, for instance, as part of it, or if we need to run a job against that web server at a later date, that we have a file that effectively runs these different steps for us. So if we were to look at some examples of what a state file now looks like, now that we've seen some commands, let's go into our file server here. This could also be instead GitHub or GitLab backed for version control, but this is just more visual from a perspective of sharing some ideas here. And so if we look at, say, for instance, first this IIS file, if we wanted to install IIS into our Windows machine, say, for instance, what we did when we first deployed this server here, which this would be its HTTP or front end, right? When we look at the IIS file, it is as simple as this. We essentially have a WinServer Manager module in guaranteeing the install of web server as a service. And so that's how we install IIS. Nginx, similar idea. So we can have an Nginx installation where we specify things such as the config file, some additional configuration code, and then here's the HTML as well. So if we wanted to look at this particular Nginx file, then we could also do so and see the front end for that. We also have Apache that was very similarly deployed. Now, when
Yeah,
it comes to
one term I just want to point out, Alonso, that Jinja term. So Jinja is actually, if you click on there, it might make sense. Jinja is just more complex. It tends to use it can use loops. It can use different functions to do far more complex efforts than just key value pairs. So that's the purpose of a Jinja file. But again, all of this is kind of just the nuts and bolts of creating states that can be deployed on a proactive basis, reactive basis, ad hoc basis, scheduled basis, but we're always just deploying states. This is VM. This is how I want you to be configured as of this minute. And tomorrow I want you to be configured this way. And that configuration can apply all the way down to the OS level or up to the application level, any particular parameters you want to tweak.
Mm-hmm. Great call out. And so what I just showed, most of that was essentially configuration files, right? How do I want my Nginx actually configured? And then this state file, this .sls file, is what we'd be applying with something like state.apply in Salt to actually run the installation of the we saw package before that was referenced. In this case, a package installation of Nginx, and then adding these particular configuration files that we've specified up here to that installation for more custom tweaking, right? And then a file managed for our module that actually helps with file system actions, such as creation of or setting the permissions, in this case, of specific files. But as we can see, all of these different steps that would normally need to be run on a web server, and let's scale that out to 10, 50, depending on your particular use cases or day-to-day needs. These can actually be codified here and then run as jobs or applied onto your actual minions. Now, an important point that Wesley mentioned was also state management. So once we've actually applied a state to our deployed virtual machines to give them an identity, right, such as a front end or a database or just a dev machine, Linux machine, then how do we actually enforce that state? And that's where we start to get into the idea of things that identify changes in your environment. An example here is beacons, and then reactors. So how do we actually react once a change has been identified to our minion in such a way that we might want to maybe bring the state back? So if we look at, for instance, the idea of a beacon reactor system, which is a very common pairing of the two, we can see that, let's actually go over to a quick additional environment here. We'll share what a reactor beacon system might look like. So in addition to having your initial Nginx state file with the deployed information, we additionally add to that minion that's running inside your system a beacon that looks for the service engine being on, and if there's a change, then it will create essentially an event. It will create an alert, so to speak, a way for the master to identify that there has been a change to the Nginx service. And then as part of the reactor workflow, how do we react to this change that has occurred? We can configure the master to say, when this happens, when we identify that there's a change to the Nginx service, rerun or start the service again. So if we were to look at, say, our Nginx service now, it's operational, and I go ahead and run a job. Let's say we're going to stop our service. So actually, let's run it specifically on our Nginx machine.
So there's a number of different ways to run jobs, by the way. As you can tell, right now it's just running a simple command, but you can also run a job, which consists of many commands. You can also run a SaltStack file, which consists of many jobs. And of course, you can target all of your VMs or subsets of VMs. We'll get to targets as well, just so you can sort of see how the GUI helps to organize all of your different environments, because you might want them organized by application, like all these VMs belong to my ERP or my general ledger system. All these belong to my HR payroll system. All these belong to this business unit. All these belong to this particular OS operating system, this Linux distribution. There's a number of ways to subdivide so that you can target them with different actions as you see fit.
Yeah, so as part of the service.stop, we essentially stop our particular Nginx service running on the virtual machine. And so the main idea here, so we see that it's been stopped. And then as part of the reactor process, what we're essentially going to see is that the master identifies that the service has been stopped and should, if our demo environment aligns, restart it, because it identifies that the service has been stopped inside the guest OS, and as a result, it reacts. The beacon has made that event to the bus that the service is stopped when it should be started. There was a change, and so the reactor goes ahead and restarts the Nginx service.
I want to reiterate, we have a master, and we have a lot of different minions. The minions are deployed in all of our different VMs. So in order to have a real-time response, you have to do one additional step. You have to have the minion install a beacon. And the beacon runs constantly, sending back event information, message information back to the master. And installed on the master is now a reactor. So we have a little bit of a nesting thing going on again. But just so that everyone understands, they're kind of one and the same. Still just a master agent workflow. And what this activity is showing is it shows where Alonso stopped the service, the second entry. He stopped it manually. And at 12:32, a minute later, the beacon reacted and sent a message back to the reactor, which took it and restarted the service because it needs to remediate drift of state. So state can be anything. In this case, the state went from on to off, and then it remediated the state by bringing it from off to on. So, all right, back to you, Alonso.
Yep, a great point. And one other thing here, as I share my other environment again, is essentially the idea that when it comes to remediation of state, that is something that can absolutely be configured and very specifically done for a given environment through reactor beacon workflows. Now, the SaltStack team, essentially, and the VMware is part of that, have taken this concept of identifying when something is not adhering to state and expanded on it to provide several fixes. And so that's where compliance comes into the picture and actual benchmarking against known industry standards. So for instance, if we wanted to remediate against sys Linux 9 benchmarks for workstations, disable auto mounting, ensure app armor is not disabled in bootloader, a bunch of different checks that need to be done on a machine for it to be, for instance, sys compliant on several different operating systems, or same with some Windows related ones as well. But ultimately, these different things that need to be done, we have several teams that assist with the creation of state files that can actually, for a good majority of sys related and some other overlapping compliance marks as well, they can actually provide you the fixed state file for these particular virtual machines.
Hey,
so that's
Alonso,
an important note there.
Are you sharing a portion of your screen?
No, I should be sharing the whole thing. Checks catalog.
Okay, I can't see the bottom. Can you scroll all the way to the bottom of that screen so we can see how many checks there are? Okay, there we go. So okay. Yeah, if you collapse that.
Yeah, so this will be for Linux.
So all benchmarks. If you scroll to the bottom, we have 5,000 checks. And let's just read a couple of these so that people understand what a check even is. These are the hardening measures that I was talking about earlier. So if you want to ensure that your USB storage, all of them on all of your machines are disabled, because that's kind of a common point of attack, this is going to check across 500 VMs with one command, and that's one check. A benchmark on it for any particular OS is going to contain all the checks that are applied to that benchmark, and the benchmarks roll up to a policy. So again, it's a nesting structure. Checks roll up to benchmarks, benchmarks roll up to policies. So you can create a policy that includes 2 or 3 or 400 benchmarks, which also include several hundred or 1,000 checks. And with one push of a button, which we'll show in a minute, where you just run the assessment, it's going to go across your entire environment and check for all of these checks. Back to you, Alonso.
Yeah, and so if there were the desire to create your own custom compliance content as well, there are SDKs available to start developing your own content. This starts getting into the not so out of the box, but what you would want to create yourself, right? But there are different SDKs for the creation of compliance content. In addition to that, there's information for creating your own content for beacons and other state files. And so we have quite a bit of guidance that we'll be providing as a follow-up to this call around how do you start with creating your own state file. And we have a multi-part process for installing a package, calling multiple states, as Wesley mentioned, even having multiple states called for a given, say, kind of server, as an example, or some kind of grouping on a top or high state. And from there, tutorials to then get you started with creating states of your own once you have a good foundation of running commands on the machines themselves. And then from there, it would be perhaps even creating your own modules, right? So using best practices.
And let me make the point.
And so on.
So Alonso's making the point that this is customizable, and you can use the SaltStack documentation, which is pretty extensive, to come up with your own desired states on whatever is potentially monitorable. However, what we were just showing a second ago, all those benchmarks and all those checks, those would come right out of the box as part of an add-on to Aria Config, known as Aria Config Secure Hosts. So it's an add-on, but if you're the kind of person who's wondering, I don't know if we'll ever use this unless we're given 5,000 out of the box or 500 different benchmarks to measure ourselves against, we might not use it. Then just know that it's an add-on. You can buy it, or you can always just create your own, or you can take some of these policies, copy the YAML, and doctor it up whichever way you want to. Like yesterday, somebody was asking me, what if I want a password to be a minimum of 6 characters, not 9 characters? Simple as copy the YAML, create a new state file, and alter it. There's also the ability to just alter the variables in a purpose-built wizard where you can change certain things like that, because I realize that people might want to alter. So all of that's part of the out-of-the-box benchmarks that I'm addressing. But Alonso, if you go to policies on the left under compliance, yeah, right there. This is the screen where you can create a policy and reference, if you want to have a policy made up of 2 benchmarks or a policy made up of 50 benchmarks. Yeah, we can just walk through the wizard real quick. It won't take too long. And these targets, again, you can create whichever ones you want. These ones come out of the box, but you could have Bob's VMs and assign all the VMs that belong to Bob. So he's selecting a couple of benchmarks that pertain to Windows. He's selecting a couple of checks. And then we're just going to create that policy and then run the assessment. And what running the assessments, and here's some of that purpose-built, password history. You can change that number, these minimums. So, but if you needed to change something substantial that went beyond changing a number, again, you can copy the YAML, create your own salt state file, paste that YAML in that salt state file. But yeah, so what we're going to do is we're creating a policy. The policy is we're going to run it here. So running an assessment is basically enforcing a policy on whatever VMs. The VMs in this scenario are all of our VMs that have Windows operating system running. And if you go over to activity, yeah, you can run it there too. We can see it, it's queued. So far, there's 0 success, 0 failed, 0 unreturned. He's clicking on the job ID. The job ID is going to, actually, I would just click on, yep. So it found some errors. So, but if we click on that minion ID there, Alonso, we'll get a detailed breakout. Try activity there. Okay, so these are the different checks that are running. And is it?
We can go back and see.
So if you click that Windows policy to the left, yeah, right there. Yeah, scroll down a little bit. Notice the check names. Those are the 4 that Alonso selected. There's only 1 VM in this environment. If there were 2, we'd have this. We'd have 2 not compliant or 2 compliant, but all 4 are not compliant. So if he selects 1, yeah, hits remediate, or you can select them all and hit remediate. And you can also add exemptions. So again, if you had like 500 checks and you want to have an exemption and say, well, don't do it based off of this criteria, you can do that. But he's just going to select 4 of these checks and say remediate. It's going to run another activity. Yep. Yeah. Did you already click remediate?
I did. Yeah, policy remediation.
Got it. So it's not returning.
Doing that.
So, and you can also show in the activity on the left, that menu, this is the global activity. So you can see activity for a particular group or activity for a particular benchmark or just all of the activity that's running. And this is what's going on right here. And do we have the job ID in there? I don't see it. There it is. On the right. All right. So we click on the job ID and it's still working its way through. And this is some of the what's going on in the command line for this one particular machine. And if you hit the job info at the top, Alonso, the tab for job info, it might have come back by now. Yeah, return true. So it remediated it. And again, Alonso, you can go back into that raw tab, what you were just highlighting. And inside of here is going to be all that activity that was happening where the check did whatever it had to do to remediate and bring that particular parameter that was not in compliance to a parameter that is in compliance. Was it password history? I took it from 0 to 24.
Yeah, it was an adjustment there on the password setting.
Okay. So that was the one state. So you set it to 24 more characters. Or was it the password age was set?
I think it was 24 more.
Okay, try to run that assessment again and let's see if it comes up compliant now. Okay, so again, let me just recap. I love recapping because I know that sometimes the information can just get squirrely. So just in terms of the DevOps lifecycle, your developers create the code, they give it over to the IT operators who put it onto infrastructure, and then past day 0, when you need to monitor, not just monitor, but take action as well against all these different VMs on a number of different things from, making sure that the password criteria is up to date, making sure that the particular application that's running on that VM or the middleware that's running on that there, or whatever appliances you have running on there are patched, or that they're in a particular configured state. To do all of that, Aria Config is going to leverage, so rather than you having to go into a command line for every single VM, Aria Config is allowing you to, with one push of a button, deploy a set of instructions across all the VMs that action should pertain to, whether it's 10 VMs, 30 VMs, or 500 VMs. And then you get kind of a scorecard here, which is showing what's not compliant, what is compliant, what jobs have been run, which ones are pending, what target groups you have. That is where the GUI really comes in, because otherwise without this GUI, this would be very difficult to manage many subsets of VMs. Again, you might have somebody on staff with a genius IQ who can keep it all straight, but do you really want your entire organization resting on his shoulders? If he or she walks out the door, there's no business continuity. So that's the purpose of this GUI, business continuity. And Alonso, if you look at the in progress, did that job run yet? Okay, so it's showing under completed. And if we hit that job, okay, so success, it did run. Okay, and if you go back to the policy, I want to see the scorecard updated. So we have 4 compliant, and instead of being not compliant. That is the point of this platform, because you know what's going to happen in a real production environment. You're going to run this, whatever script it is, across 100 VMs, and 100 are not going to come back as compliant. 99 will. There's always a VM that doesn't want to cooperate, or 10 that don't want to cooperate. And monitoring all of those exceptions, all of those non-compliant across many different criteria, I would think would be impossible even if you're a command line guru. You would need a GUI. That's what Aria Config does. It just manages the complexity of all these subsets of compliant VMs and non-compliant VMs. If you're the person wondering, could I actually use this? Yes, it's very easy. You don't have to do any custom configuration. Here's the 3 steps. You install the minion with 2 lines of code. You can do that across all of your VMs inside of 5 minutes. Once the minion's installed, that's step 1. Step 2, start running the out-of-the-box benchmarks that we showed you earlier. And those benchmarks have a bunch of checks. And then your environment's going to get hardened, meaning you'll have eyes and ears on millions of parameters instantly. And then that second step. Third step, just ongoing, run that assessment. And you'll find out when your environment comes out of alignment, when the state drifts, and then you can automate the drift remediation, or it can be done on an ad hoc basis. That's Aria Config.
As a quick reminder, right, ultimately, for the deploying of the minions themselves, we do have a bootstrap method available We also, in addition to that, once you're actually getting started with running Salt, there are cheat sheets, shall we say, to help you with getting started with commands. And then from there, moving on to reading states and applying those onto your machines. But I'd say additionally to that, Salt is a component of our broader automation platform. So if, for instance, there were infrastructure related requirements for automation, right? State related, or infrastructure as code is the common term now. State related templates for infrastructure for the underlying operating systems, I guess. We have different ways of tying everything together. So as you're looking to automate, be more efficient, and scale running those commands, there's a ton of resources at VMware, and your VMware resources are happy to talk to you about the different ways that we can help do that from an automation standpoint.
Yeah. I'll get you guys the link for that Aria Config hands-on lab. And again, look forward to, in September, we'll be going over Assembler and how that infrastructure as a code platform works to create all the VMs before you install. And you can also install the minions on the VMs. But we do thank you guys for attending today. You'll receive an email follow-up from us, I think either today or tomorrow. And you receive one from me certainly today with the deck and the link. But we thank you guys for attending and have a great rest of your day.